Hello guys, welcome back to another video. In this video we will consider an integral from 0 to 1, 1 over x ln of 1 plus x divided by 1 minus x, everything to the power of 2. So how will we do this integral? First off, to start with, we will take the 2 in the front. Let me use another marker. We will take 2 in the front, yeah, and we will have 2 from 0 to 1, 1 over x ln of 1 plus x divided by 1 minus x dx. So what will we do now? We will split this integral. I mean, not split the integral, but the ln's, 2, which multiplies an integral from 0 to 1, 1 over x ln of 1 plus x minus ln of 1 minus x, parentheses. This is 1 dx. Okay, what will we do now? We will expand the logarithms into their summation form. How does it look? Minus 1 to the n plus 1, x to the n, where n goes from 1 to infinity, ln of 1 plus x. This is what we will get for this one. And if we will use the same thing for this one, just when you put negative x instead of this one, you get negative x to the n, which is same as negative 1 to the n times x to the n. If you can see this, when you do this, when you multiply this and this, we are just left out with negative summation going from 1 to infinity, x to the n divided by n. Since n plus 1 times 1 times n, we will get 2n plus 1, and 2n is just even, and negative 1 is left, so that's the minus. So after this, we will expand those two, of course, to negative, am I missing some parentheses? Maybe, I don't know. From 0 to 1 integral, yeah, 1 over x, and now we will expand this, x minus x squared over 2 plus x to the third divided by 3, and so on. I will just write one more term. Minus, what do we get here? As we can see, we will get all the negative terms. So negative x, negative x, yeah? Negative in the front, and just expand. Negative x squared over 2, negative x squared, negative to the x to the third divided by 3, minus x to the fourth divided by 4, and so on, dx, yeah, and close parentheses. Right, what happens now is that we will combine those two. Let me see, we need one more here. Yeah, so when we, and the dx doesn't go here, but here then, I guess, or something. I don't know. Something like this. Yeah. Dx. All right. We will simplify this expression. What do we get? This is negative. The even parts are negative, and here, because of the minus, even parts will be positive. So all the even parts will be cancelled out, as you can see. This is negative. Because of the negative, this will become positive. And same goes for this one. So we can cross out all the even parts, and we are left out with odd parts. So let's proceed. In integral 2 times the parentheses from 0 to 1, 1 over x. And we will, as you can see, all the odd parts will combine since they are both positive. So we will have 2x plus 2x squared, 2x to the third. As you can see, the odd parts are positive. The 3 plus, what's the next? 2x to the fifth divided by 5. Yeah, am I right? I probably am. This will be positive, and so on. What happens now? We will, let me see. Let's erase this and continue the problem there. this one will equal this one. So we will have 2, and we will divide everything by x here. As you can see, everything is divided by x. So parentheses, of course, from 0 to 1, we will have, and of course, let's take 2 in the front, since we are doing that. Let's take 2 in the front, so just write 4. I mean, everything is 2, 2, 2. We can just take 2 in the front and divide by x. We will get, this is like 1, yeah, x divided by x and 2 in the front, 1, plus x to the second divided by 3, plus x to the fourth divided by 5, and so on, x to the let's say n to 2n over 2n plus 1. Doesn't matter, but let's write it just so people are satisfied. Put this in parentheses. Since we know even parts will be in the form 2n and divided by 2n plus 1, so this is fine. Let me just write like this. So when we integrate this term by term, what will we get? Actually, we'll get 4 times, I mean, from 0 to 1, 1 is just 1, plus 1 to the 3 to the power of 2, yeah, plus 1 to the power, plus 1 divided by 5 to the power of 2, plus 1 divided by 7 to the power of 2, and you can see the pattern. So what's happening here? I mean, let me erase some things. I need some space, since you probably are watching this video in the flowing time towards me. You don't really need to see this anymore. Okay, let's evaluate this. What is this? This is an alternating, not an alternating, but a series of odd numbers of 1 over n squared. I proved in the last video that that sum, I think, equals pi squared over 8. If I'm not mistaken, I think so. So what will we have? I mean, what is this? This is a sum of 1 divided by 2n minus 1 squared, where n goes from 1 to infinity. If you want to see a proof of this, take a look. In my last video, I did a proof of this. So we will use this in this manner. You can try to plug in the numbers and see that this equals to that. I mean, for 1, we get 1 squared. This is 1 squared. For n equals 2, we get 2 minus 1. No, for n equals 2, we get 4 minus 1. That's 3 and squared. You can see it follows from this. So our result, I mean, let me see, this equals to what? 4 times pi squared over 8, which equals to what? Pi squared over 2. All right? What can I say? This was an interesting integral. If you want to see a proof of this, you can see it in my last video. Well, that was it for this video. Like, share, and subscribe if you want to see more of this. And see you in the next video. Bye, guys.